In this video, we're going to talk about integer multiplication. And let's just review that multiplication is a way to do repeated addition. So I have some addition expressions here. We're going to use these to help develop the rules for multiplication. So I have -3 plus -3, which is equal to -6. And I have -3 plus -3 plus -3, which is equal to -9. And -3 plus -3 plus -3 plus -3, which is equal to -12, and -3 plus -3 plus -3 plus -3 plus -3 is equal to -15. And then I have -3 plus -3 plus -3 plus -3 plus -3 plus -3 is equal to -18. So now if I rewrite these addition expressions as multiplication expressions, the first one would be -3 times 2. And -3 times 2 is -6. And the next one would be -3 times 3. And -3 times 3 is a -9. And then the next one would be -3 times 4, which would be -12. And then the next would be -3 times 5, which would be -15, and finally -3 times 6, which would be -18. So when I take a negative times a positive, my product is a negative. Will this work for any negative number? The answer is yes. So then what is the rule? The rule is a negative times a positive is equal to a negative. Now let's look at repeated addition using a number line. And we'll use the example -3 plus -3 plus -3, or the multiplication expression would be -3 times 3. So if I start with -3 plus -3 plus -3, my answer is -9. All right, now let's use the commutative property for the expressions we've already developed. And remember, the commutative property means we can change the order, but our outcome or our product will still be the same. So if I take -3 times 2 and I make it 2 times -3, both of those expressions equal a -6. Take -3 times a 3 and turn it into 3 times -3, the product is -9. And -3 times 4 becomes 4 times -3, and the product for both is -12. And -3 times 5 becomes 5 times -3, and the product would be -15. And -3 times +6, if we switch those, we would have 6 times -3, and the product for both of those would be -18. Will this work for any negative number? The answer is yes. So then what would the rule be? The rule would be a positive times a negative is a negative, or a negative times a positive is a negative. All right, let's look at integer multiplication patterns to find the next rule. So we already know a negative times a positive will be a negative. So -3 times +4 is -12, and -3 times +3 is -9, and -3 times +2 is -6, and -3 times +1 is -3, and let's just do one more. -3 times 0 is 0, and we know anything times 0 will be 0, and anything times 1 will be the number itself. Now let's look at the pattern that is going on here. As one of my factors decreases, the resulting product is actually increasing by 3. So -12 plus 3 would be -9, -9 plus 3 would be -6, -6 plus 3 would be -3, and -3 plus 3 would be 0. So then 0 plus 3 would mean that I would have a 3 here. And as these are going down by 1, the next number in the factors would be a negative 1. So now I have negative 3 times negative 1 is a positive 3. A negative times a negative is a positive. And let's continue the pattern. Negative 3 times negative 2 is a positive 6, and the pattern continues. I'm going up by 3, I'm going down by 1. And let's just look at one more. Negative 3 times negative 3 is a positive 9. Will this work for all numbers? The answer is yes. So then what is the rule? The rule is a negative times a negative is a positive. So let's just summarize our integer multiplication rules. Like signs will have a positive product. So that means a positive times a positive is a positive, or a negative times a negative is a positive. Unlike signs, the product will be negative. That's a negative times a positive is a negative, or a positive times a negative is a negative. Those are the rules for integer multiplication.